Hello. Have you gotten lost while you're trying to teach yourself the backpropagation derivation? That's happened to me too. All those repeated application of the chain rule steps, all those multiple little subscripts, keeping track of what has to be done next. So in this video series, we're going to take on that backpropagation derivation in multiple steps. We'll break it down into pieces and assemble them carefully, and at the end, we'll have total mastery. In this particular vid, we're going to do an overview of the steps that we need in order to do the full backpropagation derivation. Join me. I'm Dr. Aliana J. Moren, and you're here with me in AI After Hours. During this entire series, working with backpropagation, we're going to reference a multi-layer perceptron architecture, or MLP, with an input, hidden, and output layer. I've got the notation for this in the video that was the precursor to this one, which presented actually a rationale for the entire series. You might want to check that out. This video series is actually an accompaniment to the book that I have in progress, Statistical Mechanics, Neural Networks, and Artificial Intelligence. You can access draft chapters for this book simply by going to my website, alianajmoren.com, clicking on the book tab, and from there scroll down to the orange box, which gives you a link to the table of contents. Click there, and you probably want to scroll down to part 2, which has several different chapters. Again, they're all in progress, various stages of completion. So let's get back to the subject of this video, this being the series introduction and overview. In the next vid, what we're going to do is discuss the whole notion of dependency. This isn't a psychological dependency, it's a mathematical dependency, and it's the heart and soul of what we're doing when we derive the backprop equation. This notion of dependency, or what depends on what, is really a word problem kind of thing. It's figuring out how to set up the problem so we can move forward with the mathematical steps. We're going to figure out how we can change connection weights in a neural network using the backpropagation method. This means that we figure the dependency of the output, actually the sum squared error, on any individual weight. To do this, we'll use multiple applications of the chain rule, and before we start that, we're going to do a quick review in a separate vid on the elements of the chain rule itself, and in particular, we're going to review all those little things that you learned when you were in first semester calculus, but of course we've all forgotten. So we're going to get those established, and that way, when we actually set up our equations, we can go through them pretty fast. A key element with the backpropagation method used in an MLP is that we need a transfer function that is differentiable. Everything in the whole setup must be differentiable. So we're going to use, for this vid series and in my book, the sigmoid or logistic transfer function, which is classic and fairly easy as far as transfer functions go. There are others, for example, the hyperbolic tangent. In the grand tradition of professors everywhere, we need to have something to reserve as a homework problem. Life just wouldn't be fun without some homework. Once we've established our transfer function, and of course worked out its derivative, we're pretty clear to get through the rest of the whole chain rule application process. We're going to do this in 2 parts. First, we'll figure out how to modify the connection weights going from the hidden layer nodes to the output layer nodes. That's actually kind of easy, even though the equation for that is the one that I've been showing every so often up until now, just to, strike fear and terror into our hearts. Then we do the second one, which is the input to hidden connection weights. That's actually a good deal more complex, but by that time we'll be suitably warmed up and we can rip right through it. That will officially complete the mathematics of our backpropagation derivation. However, we're going to have one more wrap-up vid where we encapsulate everything and sort of get an intuition as to what these equations mean, how they've impacted the role of backpropagation in neural networks, how the limitations of using just backprop alone led to the neural networks winter, and how the Boltzmann machine emerged as having a significant role and in fact giving us deep learning starting in about 2006. Thanks for joining me, folks. This has been part 1 of a 7-part series in neural networks backpropagation, and you're hearing me conclude this vid in the very early morning hours where we have rooster accompaniment. To make sure that you get all the vids in this series with or without the roosters, please go to my YouTube channel and do the like, subscribe, and notify. We've got a total of 7 vids in this series, plus the part 0, Rationale, and I'm sure I'll throw in a few more just for fun. See you soon. Thanks and goodbye.